Hi there once again and welcome to another Expresso Mechanic Python tutorial. And in this one we're going to be building what I'm calling a conveyor effector. And you can see the way this is working. It basically moves the cube from one side of the device to the other. And when it gets to the right hand side you'll see that it will reverse and send the cube back in the opposite direction. And it will keep on doing this. Once it gets to the left hand side it'll just reverse again and send it back to the right hand side. So it's kind of a perpetual conveyor belt idea that I'm putting across here. Right, so that's what we're about. So let's just stop the timeline. We'll change our view and we'll see what we can do to make this thing work. Okay then, so we've got our coding layout switched on and we can start again from here. I just got rid of the Python effector there and I'm going to create a new one. In fact, what I'll do, I'll select my cloner and then create my Python effector. Okay, great. And straight away, as always, something happens. And if we switch to full control, something else happens which we don't want. All we need to do is the usual thing. Take the loop away, hit execute, and everything goes back to normal. Okay, what do we need to do first? Well, let's just have a quick look at the dynamic setup for this, because obviously the cube and the cloners are actually, or the clones in the cloner are actually dynamic, as indeed is this base object, which the clones are residing in and forms the superstructure of the conveyor. So that's just a collider body. That's all that's got on it. It's just a dynamics body set to static mesh. Nothing's really been changed in here. The only thing I'm using is a margin of 1%, or 1 centimeter I should say. That's all I'm using in there, and I've got a bounce and friction of 10%. That's the same across the board. So the cube here, which is a cube that we're moving, that cube it's 16 by 16 by 16. You can make yours whatever size you like, but there will be changes you'll have to make if you make it any bigger. But 16 by 16 by 16 is what I've got. And in the dynamics, absolutely everything the same. Obviously it's a convex hull though, not a static mesh. I haven't used that this time. I've used a convex hull, and I've got the same setup as the base from now on. So everything else is exactly the same. The same applies to the cloner. I've got the dynamics tag on the cube in the cloner. You can, if you wish, put it on the cloner itself. If you do that, you've got to change the inherit to apply to children, and the individual elements needs to be set to second level, and that will work fine. Again, convex hull, a 1 centimeter margin and 10% friction and bounce, and that's it. That's the setup that I've used. Now these cubes in the cloner are 17 centimeters by 4 by 17, so they're a little bit bigger than the cube. If we just take a look from the top, you can see that there. And obviously the base is just, well, it started life as a cube and I just manipulated it into the actual shape by simply using, well, I divided it up into the correct number of into 10 subsections essentially along the x-axis, and then it was a case of selecting faces and then extrude inner and an extrusion and a little bit of bevel and stuff like that just to make the thing work. I've got a bevel deformer in there, and that's all I did. So quite simple. Obviously with this the base is going to be a little bit bigger still, so the base is 200 long in the x and then 20 and 20 in the y and z. So that's the dimensions that I used for that. But you can make yours a different size if you wish, but you will have to make some changes within the Python, but not massively. So anyway, that's what we're doing there. Right, so let's get into the Python and see if we can make this thing work. So the first thing we need to do, we need to say from Cinema 4D, so from C4D, import and utils, because we're using a range mapper and that's where it's hidden away, it's stored away in the utils module. So that's what we need there, the first thing. Our next port of call is to create the frame variable that we use so often, because we do need, for a range mapper of course, and for a monoflop which we're also going to create, we need to take the frames from the timeline down here, and that's what we're going to do with this variable if you've never seen any of the other tutorials. So the frame is equal to, so we're going to say doc get time get frame get FPS open, close, close. And I also need to put doc in front of that just to make that work properly. Bit of a mouthful, I always say, and it certainly is, but it gets us our frames from the timeline. That's all we're about there. Okay, now the has field is mentioned here at the bottom. This is going to be the last thing we do is update the MoData matrix array. So we're not going to take away the has field line here. We'll leave that in, even though we're not going to use it. Full, technically you could take that out, but I just leave it in, even if I'm not using it. It doesn't do any harm, so I just leave it there. Right, so let's start putting a few variables in. So the first thing we need to do actually, or the next thing we need to do, is create some user data. So we need to select our Python. I'm just going to bring it down there, and we'll select our user data tab here and just say add user data. First thing I'm going to get in, I'm going to call it cube, because we're going to be working with our cube object, and we're going to call that one, or select for the data type, we're going to call it a link, and that's what we need there. Add data again, and in this one it will be spline, so we're going to call this pivot, and it will be a spline. And this will be used later on when we put our monoflop and our range mappers in. We've got two range mappers for this actually. What we're going to be doing, we've got one range mapper that's going to be raising the cubes up, and then the second range mapper is going to be used to pivot the clone once it's in the correct position with regards to its height, and that will lift it up and then tilt, and the cube will slide off and move to the next one. That's what we're doing here. Okay. So if we add another spline and we call this one raise lower, and again in our data type we get a spline, then we're ready to go. So they're both in there, and the first thing we can do in our object is to drag in our cube. Just drag that one in there. I'm going to change that to cube so that we don't get confused with the one in the cloner. That's absolutely fine. And then from here we can develop our splines. Firstly, in the pivot, well rather I'm going to do the raise lower first. What I'm going to do, I'm going to put a point at the bottom, and that one, if we just twirl this open, we can just see exactly what we're doing. So point X and point Y, they do need to be 0, 0 for the first one. That's absolutely fine. And then what we'll do is add another point, and we'll take this one up to 0.3 on the X-axis and 1 on the Y is absolutely fine. And we'll go to 0.7 for the next one on the X-axis and 1 on the Y. And then we'll finish it off with another point right down at the bottom there at 1 on the X and 0 on the Y. And then we can look at the tangents. So the left tangent, I'm going to say minus 0.125. The same at the top, see what it's like, it's 0.083, so we put 125 in there. Check this one. That's already correct. And this one, we're going to make 0.125. So we've made everything even, and if you've seen any of my other tutorials, you'll have seen it's the same formula that I'm using here. Now in the pivot, what I need to do is make this happen. So what we've got here, we're going to be raising, and we've got an ease in out curve here. We're going to be raising for a third, effectively a third of the cycle of the animation there, and then we're going to pause here, and then for the last third we're going to drop back down again. Okay, so that's what we're going to be doing. It's quite simple really. That's all there is really to it. So what we'll do is set our first point in the pivot spline there, and then our second one we can say, we'll twirl this out of the way and then twirl this down. That wants to be 0.3, the second point. So we're going to pause while we're raising, and then we can put another point in here, and we'll make that one 0.5. We'll try 0.5, or either 0.5 or point. I tell you what, we'll go 0.4. We'll go 0.4 with that, and then over here we'll go to 0.6 because we still want a bit of a pause at the top here as well. So we'll go 0.6. Then we'll come down to 0.7 on the X down here, and then finally finish it off with a point at 1 and 0. That's absolutely fine. And then again we'll take a look at our what word am I looking for? Our tangents. I'll get there in the end. I'm getting old. Okay, so our left tangent we'll say minus 125. We'll see if that works, and that does work for us. It's still okay. Do the same up here. That's good. And the same there. That's already there. And the other two, really, we can just leave them because they're just flat anyway. So there's nothing really much going on there. We can move that just a bit over there if we wish to. Make it 0.9 or something, or 0.8. That's absolutely fine. Yep, so that's our two splines set up, and they will work in harmony together. And you can see, so we're raising here, then we get to a pause on the raise, and as soon as we get to the pause on the raise, we tilt, a little bit of a pause there, and then we tilt back, and then we start to lower. That's exactly what's going to happen there. So that's all set up, and that's going to work great, but we won't be needing that until a bit later. Right, so the next thing we need to do then is start dragging these in, because we need to use these as user data so within our code. So if we drag our cube in first, we can simply say obj for object is equal to op user data number 1, and we'll drag our pivot in and do the same thing. Pivot is equal to op, and then finally raise lower. What I'll do with that, I'll just give myself a little bit more space. With the raise lower, I'll drop it in there, and I can say I'll simply call it RL. I think because it's a bit of a mouthful saying raise lower, is equal to op, and that'll do fine. Next thing I can do is set some global variables, and there's only 4 global variables that we actually need for this particular expression to work. So we can say global direction, because we know that this moves both across the screen and back across the screen in the opposite direction, so we need direction. And then we also need global clone, global trigger, and global start time. And these are all for our range mappers and our well, they're for our, we need to get the clone that we're currently working with, and the trigger and the start time are of course for the monoflop if you've done any other tutorials. Okay, so that's done that. The next thing we need to do is come down to the bottom here and start setting up our variables. So we can say that if frame is equal to 0, so if we're at the start of the animation, then we're going to initialize our variables. So they're all just empty lists. So the clone is equal to an empty list, trigger exactly the same, start time is the same, is the same, and finally direction is different, because direction does need a number 1 in it. So what we're going to be doing, if direction is equal to 1, we're going to move from left to right. If direction is equal to 0, we're going to move in the opposite direction from right to left. That's how this is going to be working. So it's a flip-flop. It's kind of a flip-flop situation that we're going to be developing here. The next thing we're going to need to do is define our function, and we've only got one, and we're going to call it convey. So first thing we need to do is set up a for loop. So for I in range count. And as for those who've not done any tutorials of this nature before, this variable up here gets the number of clones within the cloner. So we're going to be working with all 10 of these in a cyclic situation. So that's what we're going to do. We're going to be sequencing through them using our for loop. Moving on from here, we need to set up our distance vector. So that's what we're going to do next. So firstly, we need to say pos is equal to object dot get abs pos. So we want the absolute position of our cube within our 3D space. Next, we need to set up a difference vector. So we can say diff vect is equal to mar brackets I minus pos. So what are we doing here? Well, for anyone who doesn't know, again, a difference vector is the difference between the current clone and the cube. So let's have a quick look. Okay, so here's our cube and here's our current clone. Now our current clone, we can actually see the actual axes here. So you can see that that current clone has actually got a set of axes. That's just a coincidence actually, because they're not the axes for the clone. They're the Python effector's axes, but they're in exactly the same position as the axes for the clones. Okay, so they've got their axes in the middle of them, and the cube will have the same. And this vector is the difference between those two. Okay, so that's what we're doing there. Moving on from here, we need to create a distance vector. So dist vector is simply equal to diff vect dot get length. It's the same formula that we've used in other examples of this nature. So whenever you're making an effector that responds to an object within the scene, you will need to use this formula. So that's giving us the length of the vectors, or the vector between our axes of our clone and the axes of our cube. Whatever that distance is, that's what this vector represents. Okay. Moving on from here, what we need to do next is check the length of our distance vector. So we can say if our distance vector is less than. Now I'm going to use 11. 11 is the sweet spot for this. So what we've got here then, we know that our clones are 4 centimeters in height. So the actual axes will be at 2. So there will be 2 centimeters between the midpoint and the top of that clone. Our cube is 16 units in height. So half of that is 8. So that gives us 10 if we add those two together. And I'm allowing a little bit extra for the cube actually being... It's because the cube will bounce. It will bounce slightly. So if you want to allow a little bit, just a little bit for that extra bounce. I mean, they are touching. It's because we've got the collision margin and everything set up. They are touching. But nonetheless, we want to allow a little bit. So if it's less than 11, that's what we want to say. Don't go 10 or don't go any less than that, because you are sort of playing with fire if you go too tight on these. Less than 11 is actually fine. So if the distance vector is less than 11, we can say if len clone is less than 1, clone dot append I. So if once we've got our cube within range of a clone, we get that clone's index value. That's what we're doing. We can also then say if len trigger is less than 1, trigger dot append 1. As I've said before, it doesn't matter what you put in there, but just put 1 in there. It's just the easiest thing to do. And then finally, if len start time is less than 1, start time dot append frame, because we want our current frame as the starting point for our range mapper and our monoflop. So that works perfectly fine. Moving on from here, we can say if len trigger is equal to 1. This is where the fun starts, so we can get our monoflop sorted out and get our range mappers moving so that we can get our clones conveying our cube. So we can say duration is equal to frame minus start time 0. So we're going to take away the current frame from the current frame, technically, to create a 0 point for the starting point of our monoflop, as we have to do with Expresso. I've said this before, but it is worth reiterating yet again for people who haven't done these tutorials. Moving on, I'm going to do this over approximately 2 frames, or not 2 frames, 2 seconds. So we're starting with 0, so we can say if duration is less than 59. We can do 60 if you wish, but if we're going to be pedantic about it, 0 to 59 is the same as 60 frames, which is 2 seconds. So that's what I'm going to do here. I now need to check which direction the cube is moving in and change that direction if need be. So I can say if clone 0 is equal to 0 and direction is equal to 0, I can clear, well, actually what I'm going to say, again I must reiterate this, you can either say direction dot clear or you can say delete direction So 2 different methods of clearing the direction list. If you're in release 23 for Cinema 4D, use direction.clear. If you're in earlier versions, use del direction within 2 square brackets. This is because you're using an earlier version of Python in those releases of Cinema 4D, and they don't have this convention within them. Okay, so bear that in mind. But I'm going to use direction.clear because I am in release 23. Not that I'm bragging or anything, but but yeah. So that's why I'm doing that. So if clone is equal to 0 and direction is equal to 0, direction.clear, and then we can say direction dot append 1. So what are we saying here? So we're saying that if our clone for our, just change my view, and what I'm going to do is go into my cloner, go into my transform, and give us our index values. Okay, so if we're at 0, so if we're at the left hand side of the machine and we're traveling from right to left, because our direction 0 is right to left, then we must clear our direction list and set it up with a value of 1. Okay, we've got to append it with a value of 1, and that will mean that we would then be traveling left to right, which is exactly what we would need to do in that circumstance. Moving on from here, we simply need to copy this and say, let's just take that back one space. Hang on, not too good. That needs to be there, and they need to be there. We can then say if our direction, or if our clone is equal to 9, because we would have hit the right hand side of the screen or the right hand side of the machine, and our direction is equal to 1, well then we need to come back towards the left. So we can say append 0 to change the direction again. So that's what we need to do there. We need to check those things and then set them up if they need to be changed. Moving on from here, we can say if direction 0 is equal to 1, rotation is equal to 22, and then I can say else rotation is equal to minus 22. Now these are in degrees. So if our direction is 1, so if we're coming from the left to the right, then every time our clone lifts, it needs to pivot so that it pivots towards the right hand side. So it will need to pivot by 22 degrees. Obviously, if we're going the opposite way, it needs to pivot by minus 22 to move the cube towards the left hand side of the machine. That takes care of that. Our next border call is to get our range mappers and our, well, all of our range mappers working basically. That's essentially it. So we just got to start with pivot. So we'll say pivot range mapper is equal to c4d.utils.range map brackets duration, comma. Now we're going to go from 0 to 59 frames as our input range, or our input values, or our range is the duration. These are our input values, as you may have done if you've done any work with range mappers within Expresso. It's the same setup. I'm just going to give myself a bit more space. And then our output range is going to be 0, comma, rotation, whatever that may be. It's going to be either minus 22 or 22. And then we can say false in here, and this is going to be important. Let's just get that typed correctly. Now, the reason I'm putting false in there is because I don't want to clamp these output values. If I do, they'll only work when the rotation is 22. Minus values, if you put true in there, you won't be able to work with minus values. So always bear that in mind, okay? If you're working with any kind of minus value, always put false in there. Otherwise, it ain't going to work. And then finally, we just need to end with pivot because we're using our pivot spline. So that's as much as we need to do in there. Now what we can say next is that rotation is equal to c4d.utils.matrix rot, and it's Z because we're going to be rotating along our Z axis. And then all we need to say is c4d.utils.rad for radians, because we're going to convert degrees to radians, and then we're simply going to say pivot range mapper. So whatever value is coming out of this variable, this range mapper variable here at the output, so the 0 to 22 or minus 22, we're going to be using that value in our rotation, in our rotation variable there, and that's all we're going to be doing. And then finally, to get our rotation working, we simply need to say mar clone 0 is equal to rotation. And that works. We don't have to say times equals here. It doesn't have to be. It will work with simply rotation. I'm not quite sure why that is. Normally you do need to say times equals when you're using rotation variable, but I've found on this occasion that it works without saying that, which is very, very interesting. I don't quite know why that is. So that's our rotation dealt with. We're going to do our height now. So in our height, we simply say RL range mapper is equal to I've just realised I've put an extra bracket on there. I don't need that one. Right, we need to simply say is equal to C4D dot utils dot range mapper duration 0,59 once again, comma, and then we've got a height value, and that's going to be 6.5. So we only want it to go up 6.5 centimeters. In here I can say true because I can clamp that value this time without any problems, and I simply need to say RL. I think that was what I used, didn't I? I just said RL. Yep, RL, that's absolutely fine. So that will be our raised lower spline. Moving on from here, I've got to do vectors to reals, so I need to say x is equal to mar clone 0 dot off dot x. Y is going to be equal to RL range mapper. Because it's our height that's changing, the x and of course the z are going to stay the same. So we're going to copy those and paste that in there and simply say z and then change this to z2. So that's our vectors to reals dealt with. Our next port of call is to create a vector to get the clones moving. And that being the case, we can say mar clone 0 dot off equals C4D dot vector brackets, and normally it would just be x comma y comma z. However, we've got to do something a little bit more to the x-axis of the vector. We have to actually say x plus clone 0 multiplied by 20. So why do we need to do this? Well, I don't absolutely know how MoGraph works on an internal sort of level, but I've discovered that if you don't do this, something very strange happens. Whenever any of the clones other than clone 0, which is currently at the center point of the world, is within range of the cube, what will happen, that clone will jump back to the 0 point. So if we were over here, this will literally jump from here right over to here. Now I don't know why that happens, so the only way to stop it is to get the clone's index value and multiply it by 20. So obviously clone 0 multiplied by 20 is 0, so that will be left in its current position at the center of the world, and that's fine. Clone 1 is going to be times 20, so that's going to be here, times 40, 60, 80, 100, etc. by using this formula. Now it is odd, I don't know why it happens, but it just does, and it's something to do with the internal workings of MoGraph. I'd like to know a little bit more about that, but as I say, I don't know why it happens, I just know how to fix it. But anyway, that's something we have to do there, so always bear that in mind when you're working, certainly with a linear cloner like this one, because this is a linear cloner, it's not a matrix array. Okay, so that's something to bear in mind. So it's actually something I should have probably mentioned earlier. So we just go to the object here. Yeah, so I've got it in linear mode. That's the only thing that's different about this effector from all the others that I've sort of done so far. Okay, but yeah, I don't know. It's one of those strange things. It's just the way that MoGraph seems to work. Okay, so moving on from here, we can say else, and then all we've got to do is reset the variables for the clone, the time, start, and the trigger. So if we say clone dot clear start time, well, actually we'll do trigger first. Trigger doesn't really matter, but we'll do trigger first. I always do trigger dot clear, and finally start time dot clear. Once again, use the delete or the del protocol if you're using an earlier version of Cinema 4D. That's the only difference you need to worry about there. And down here, it's already in there actually. It's just I've just put a return at the end of my function here. That's just a way of making the thing tidy. So just put return at the end of there. And then the last thing we need to do is simply come down to here and say else, and then call the function. So we can just say convey. And all things being fair, if I haven't made any mistakes, this should work. So let's give it a go. Let's see what happens. And we have made a mistake, so let's see what we've got. So in line 29, let's have a look. Let's have a look at that. So difference vector. Okay, I can see what I've done. Schoolboy error. I should have put dot off there because I need the offset value minus the position. That's fine. So that's okay. Let's see what we've got now. And we've got another one. So we've got clone not defined. Where is this? Line 33. Let's have a look what we've got here. If then clone is equal to. So what have I got? I've got global clone. What have I got down the bottom? And I've got clone there. So what is going on here? Something is. So then clone. It must be something to do with something else probably. Let's have a look. Let's scroll down and have a look in the main body of it here. So what have we got? Okay, direction. Ah, I can. There's one. If direction 0 is right, okay, there's one error there. They should both be direction 0. That will give us a problem if they're not. Okay, that's cleared that one. Have I got anything else? Was it rotation is equal to that's spelt wrong. Matrix, not Martix. Matrix, no, that's still wrong. No, matrix, that should be right. Matrix rotation Z, that's correct. And what else? We got anything else? Range mapper. Yeah, range mapper. That should be range map, not range mapper. Everything else looks good. Yep, let's see if it works now. Let's see what happens. Yep, we're away. Let's just see if it works absolutely correctly and changes direction when it should. All looking good so far. Hooray! Perfect. Yep, it's working exactly as it should. That's great. And I've set the timeline up so that it actually loops. So it'll start coming back the other way, but that's only because the timeline is looping. But I should be able to set the timeline up, or I can set the timeline up so that it will actually come back again anyway, because it's working perfectly well. Okay, that's great. Really nice. Okie dokie. Well, there's one other thing as well. I've got up here, I've got an important note. So let's just see what I've written in there. So it says there is a need. Let's just move this out a little bit so we can see this. It says there is a need for the cloner's position to always be at 0, 0, 0 when working with distance vectors. As if the position is offset, said vector will not work correctly. Therefore, if you need to move the cloner away from the center of the world, it must be placed inside a null. This maintains a local position of 0, 0, 0. The distance vector's length will change, but in a relative way that still allows it to function correctly. So that's going to be important. So if you make something like this and you do not want it to be at the center of the world and you want it anywhere else in the scene, always put the cloner into a null object and then you'll get it to work. Otherwise, it just ain't going to happen. So that's important to bear in mind. But anyway, it's all good to see that this is working. It's doing exactly as I said it would, which is always a good way to end a tutorial with what you've been teaching actually working. So that really is about it for this particular one. So I hope that it's been of interest to you and you've learnt a bit from it if you're still with me at this point, and I hope you are. I hope some of you are at the very least. I know some of you won't be. But anyway, that just about completes this tutorial, so I will be seeing you very soon on the next one. But before I go, if you have enjoyed this tutorial, please give it a thumbs up, and if you feel that the channel is worth subscribing to, then please do so. I'll see you very soon. Cheers, bye now.